Hi guys, welcome to section 3.1 and 3.2. We only have 2 sections in chapter 3, so it's going to go by very, very quickly. And the next thing we have to do is our midterm. So for your warm-up today, we're going to start reviewing for that exam. So pause here, do numbers 1 and 2 from earlier in the chapters we've learned before, and return back for your answers. All right, number 1 is calculating the distance and midpoint. So for distance, we remember have the formula, and you can have that long formula, but remember my shortened version is finding the distance between the x values. So -4 and 4 are 8 spaces away, and we square that number. And then 0 and 7 are 7 spaces away, and we square that number. In order to get 113 underneath the radical, you would try to do your little tree with that to simplify, but you cannot, so you're just going to leave it as square root of 113 unless they wanted a decimal answer, and of course you would type that into a calculator. And then midpoint is our formula where we add the x's and then divide by 2, add the y's, divide by 2, to get 0, 7 halves. If you wanted to put 3.5 for 7 halves, that's totally fine and acceptable as well. All right, number 2, so points, the reason I want to put this on here is that a lot of the vocab of chapter 1 is what people were messing up on the chapter 1 test, and that should be probably one of the easier parts of a test is a vocabulary part and not the mathematical part. So I wanted to go over this section with you guys as well. So it says, is BCF an appropriate name for plane R? BCF is not an appropriate name because they are 3 collinear lines, or 3 collinear points, sorry. What we need to name a plane by is 3 points, but they cannot be collinear. So you just need to give me 3 random points, like BAC, that could be a name. BEC, that could be a name. You just can't have 3 on the same exact line. You can have 2, so you could have, say, BCE, that's fine, but not 3 on the same line. Part B, what is another name for plane R? We just kind of went over it. As long as you pick any 3 of these points that are in the straight line, then you are totally fine. Name the intersection of lines M and T. So M and T intersect at point C. So 2 lines always intersect at a point, and that point for this one is C. Part D, name a point that is not coplanar with A, B, and C. So A, B, and C, a point that's not coplanar is something that's off the plane, so point D. In part E, name a point that is collinear with H, so just basically on the same line as H, so you have line L, or point L. All right, so what is chapter 3? Chapter 3 is going to be your transformation chapter. All pretty logical and things you've probably seen before. We're just going to probably give it more a mathematical approach to this. So a transformation is a change in the position, size, or shape of a figure. Kind of think of your Transformers, like the movie. So we have a couple of vocab. Again, hint, you guys need to really pay attention to the vocab. I don't want you missing that ever on a test because that should be the easy part. So for vocab, pre-image is the original figure. And then you change the position, you change the size, or you change the shape of a figure to its image, the resulting figure. So we start off with a pre-image, we move it somehow and make it a new image. So an arrow shows a transformation. So you're going to see that in writings here. And then the little asterisk is called a prime. And that's what we call and label the image after it's transformed. So the way you're going to see this written is triangle ABC got transformed to triangle A prime, B prime, C prime. That's what we're going to call these. All right, so we have 3 transformations that we're going to concentrate on in this very short chapter. We have a reflection. A reflection is across a line. As you guys know, a line of symmetry usually is what we call it, or the line of reflection. The most important part mathematically we need to understand is that each point and its image are the same distance from the line of reflection. So for example, mathematically, we're going to have to realize that, for example, if this is 2 spaces away, this one has to be exactly 2 spaces away as well. So we have to make sure it's mathematically the same distance across a line of reflection. Rotation is going to be in your next lesson, but rotation is just, as you guys know, like a pivot or a point, something that is transformed across a point the same distance from P. So like a basketball player pivots around their foot, so they'd be like going from this side, pivoting to this side. And as we know, just like the reflection, these have to be the same distance as well. So it has to be like if this was 3, this has to rotate accordingly to another 3 units as well. And then translation we're also going to do in this lesson. So translation is all the points of a figure move the same distance in the same direction. So this is talking about like moving to the 8 units to the right or moving 2 units up, those type of things. You're just literally taking the movement and you're just shifting it around. So really in ALEKS, some of these topics are very, very easy. So as you will see right here, all you're going to do is tell me which type of transformation is happening here. So for example, for the first one, this is a rotation. Number 2, you can see that this is going to be a reflection. If they had this imaginary line here, one image just got reflected over to the next. The next one, the images are exactly the same size, just one moved down or moved up, depending on which one was first. So this is a slide, which is also known as a translation. The next one you can see is a rotation. Okay, repeating on this one just slid, so it is a translation. The second one is a rotation, as well as the third one. And then the last one you can see was flipped across an imaginary line, and that would be a reflection. So in ALEKS, a lot of these are identifying what types of transformations are happening. And then we're going to get down to actual moving these in mathematical ways to see these. All right, so we're going to practice 2 things in these next couple problems. We're going to complete the translation that they're asking us to do. Then the most important part mathematically is to write a rule for the translation. So we're going to pay attention to 2 different things here. So the first part is going to be very easy. You're just going to, basically on ALEKS 2, it's going to be, you're just going to pick these images up and slide them around. On your notes right now, it'd be nice if you just traced these images and then cut them so you can move these accordingly. So translate this figure 8 units to the left. So you're just going to move 1, 2, 3, 4, 5, 6, 7, 8. So you're just going to move them 8 units to the left, and that is your resulting figure. And that's all you would have to do on ALEKS. And again, for me, let's practice writing a rule. So how do we write a rule for these? So you start a rule always by x comma y, and then an arrow. So all your rules will always look like this at the beginning, every single one. So you can always at least start off writing like that. Then you're writing in here what you would do to get the resulting coordinate. So translating a figure 8 units to the left, does that affect the x coordinate or does that affect the y coordinate? And you should know it affects the x coordinate, right? So I went from like this point 4, -4, all the way to -4, -4 over here. So I changed the x coordinate basically. So you would say x minus 8, because it got shifted 8 units to the left, and the y coordinate stays exactly the same. So this rule basically tells me that if I do any point of translation 8 units to the left, I could put any numbers in here and the resulting image would be perfect if I did the math in there. All right, number 2, translating this figure 7 units to the right. Again, it'd be easiest if you just trace these images. That way we can just grab them and move them accordingly. So 7 units to the right would end up there. And then we need to write the rule. So the rule always starts off with x comma y, arrow. So that means this coordinate is being transformed and the rule is 7 units to the right. So again, you try to ask yourself, which part is being affected, the x part or the y part? If I'm going to the right, what is going to change? Well, we know the x part's going to change. So you would say x, and then to the right would be plus 7. And then the y part did not change. And again, if that's confusing, look at the point. So for example, this is -4, -3. And we ended up at 3, -3. And doesn't that rule make sense? So the -3 stayed exactly the same because the y stayed the same. And then the -4 went to +3 because you added 7. So the rules should take care of themselves with the points there. All right, number 3. So we're moving this now 2 different ways. So we're just adding a second translation, but same idea. So trace your figure. And this is going 7 units to the left and 8 units up. So it should be here for the 7 units to the left, and then we're going to go 8 up, which should take me here. Okay, then again, we want to write a rule. So we're going to do x comma y. Okay, the 7 units to the left, that affects the x coordinate, so it's x minus 7. The 8 units up affects the y coordinate, so you're going up 8 units, so y plus 8. So now, without a graph, let's try to do 2 more of these problems. So this one says, in the coordinate plane, the point x -4, -2 is translated to x prime -2, 3. Under the same translation, we want to translate the y and the z coordinates. And then we have to find, obviously, the new coordinates of y prime, z prime. So first, we need to find what the rule is. How did we get from -4, -2 to -2, 3? So let's find that rule. So the rule is going to be x comma y. So you ask yourself, how'd you get from -4 to -2? So it means you added 2. So your rule is going to be x plus 2. Then you're going to look at the y's. How'd you get from -2 to +3? You added 5. So y plus 5. Now you can take those rules and apply them to the coordinates that they gave you. So you apply it to y and apply it to z to find your new y and z. So y originally was -6, 2. We're going to move it to y prime by using this rule. So we're going to add -6, we're going to add 2 to get -4. And then 2, we're going to add 5 to get 7. So that's your new y prime. Let's do the same thing with z. So z starting out at -8, -5. And we're going to make it z prime. So to the x's, we're adding 2. So we're going to get -6. And to the -5, or to the y's, we're adding 5. So we're going to get 0. So here are your answers, -4, 7 and 6, 0. So try the next one all by yourself and then return back for the answer. All right, for number 5, make sure you have the rule written correctly and that you have the correct b prime and c primes listed. So those were all translations, and now we're going to end today with reflections. So reflections, you are definitely familiar with, but we're going to talk about more mathematical ways to approach these as well. So it says reflect the point A across the y-axis and then across the x-axis. So give the coordinates of each. So we have A prime on the bottom, as you can see there. That coordinate, so A, is 6, -9. So if I flip this across the x-axis, reflect it across this axis, this is going to just go all the way up to here. So that's going to be 6, 9. We'll call that A prime. So A prime is going to be 6, +9. Now let's do the y-axis. So the y-axis is going to be across this line. So this is going to move like over here somewhere. But again, it has to be the same distance. So since this is 6 units this way, we need to go 6 units to the left. And we're going to have and this is, I'm going to call this double prime. So if you have multiple shifts, we're just going to add to it. So a double prime is going to be at -6, -9. So always making sure the distances are exactly the same from the line of reflection. So as you can see here, the reason I wanted to do that is I wanted you to see what changed from the original. So with the x-axis, if you compare these two coordinates, what changed? As you can see, the x-coordinate stayed exactly the same. The only thing that changed was the y-coordinate. And then similarly with the y-axis, the y stayed the same, and the only thing that changed was the x-coordinate. So here is what I want you guys to do when you guys are reflecting across a axes. I want you to think the opposite. If you're reflecting across the x-axis, just change the sign of the y-coordinate. And then if you're reflecting across the y-axis, just change the sign of the x-coordinate. So for example, number 1, it says reflect the point -3, -8 across the x-axis. So that means I'm going to change the coordinate of the y-coordinate. So the -3 is going to stay exactly the same, and then the -8 is just going to become +8. And then part B, we want to reflect this across the y-axis. So we're going to keep the y the same, and all we're going to do is change the coordinate of the x-axis. Number 2, same idea. So we have reflecting across the x-axis, that means change the y. And then reflecting across the y-axis, that means change the x. And now that we've been practicing writing rules for these reflections or transformations, I want you guys to see if you can write a rule for reflecting across the y-axis. So for example, this will be x comma y arrow. And then what changed with the y-axis? So with the y-axis, all we do is change the sign of the x. So I'm going to put -x, and then the y stayed exactly the same. So that would be your rule if you were asking to reflect across a y-axis. And then reflecting across an x-axis, the x stays exactly the same, and only thing we change is the y part. All right, lastly, we're going to talk about being reflected and translated. So we're going to put everything together. So with number 1, it says draw the following quadrilateral after a translation 2 units to the right and 3 units down. So again, in ALEKS, you're just going to have to pick this figure up. So on our notes, we're going to copy and then drag this around. So 2 units to the right and then 3 units down. So you're going to have problems like that are easy, and then you're going to have like reflection ones on that too, and there's a button in ALEKS as well that you can use on that. But then most of the time, especially on tests and quizzes, you'll have problems that have words instead of graphs on them, as you can see below. So number 2 says translate 5-1 to the right 3 units, and then we're going to reflect that new point across the x-axis, and what is the final point. So I just want you guys to do this slowly. Please don't try to do this in your head. You're going to make small careless errors. So let's write down the first coordinate. Then I like to draw an arrow and do the next translation. So this one says right 3 units. Okay, you have to ask yourself, does the going right and left affects the x or the y? It affects the x. So going to the right 3 units means I'm going to add 3. So this will become to 8, 1. Then I'm going to reflect that across the x-axis, which means I'm going to change the sign of the y coordinate. So then my final answer is 8, -1. And if you're having trouble with that, try to imagine it on a coordinate graph. Like if you're going to the right, like if you had a point here, if you're going to the right, try to think, what does that affect? Oh, that affects the x-axis. All right, number 3, translate 5, -5 down 3 units, and then reflect it over the x-axis. So we're going to start with 5, -5. Down 3 units affects the y-coordinate. So I'm going to subtract 3 from -5 to get -8. And then reflecting that over the x-axis affects the y-coordinate. So we're just going to change the sign of the y-coordinate and get 5, 8. So try the last one all by yourself, and you'll be finished with the first set of Chapter 3 notes. All right, you should get 7, -4 as your final answer on number 4. You guys can now start your ALEKS topics and homework on this. Please come see me if you have any issues.